Have you ever wondered how large AI platforms deploy complex systems like AI agents, inference servers, vector databases, and monitoring tools without manually running commands on servers? In modern AI infrastructure, everything is automated and version controlled. Today, I'll explain how companies package every AI service as Helm charts, deploy them using GitOps with ArgoCD, and manage production environments safely. If you're interested in AI engineering, DevOps, and platform architecture, this video will give you a clear understanding. Packaging AI services with Helm. In modern AI platforms, every service is packaged using Helm charts. This includes components like AI agents, inference servers, vector databases, and monitoring stack. Helm charts allow developers to package Kubernetes applications in a reusable and versioned format. Each chart is stored in a private OCI registry, such as AWS ECR or Azure ACR, making it easy to manage versions and deploy consistently. Helm chart structure. A typical Helm chart contains several important files. Chart.yaml. This file contains metadata about the chart like name, version, and dependencies. Values.yaml. This file stores default configuration values for the application. Values.prod.yaml, used to override values for production environments. Templates folder. This folder contains Kubernetes manifests, such as deployments, services, and config maps. Helpers folder contains reusable template functions used across the chart. Smart configuration with values.yaml. One best practice in Helm is not hard-coding configuration values. Instead, all environment-specific settings are stored in values files. Examples include image version tags, replica counts, CPU and memory limits, Kafka broker addresses, vector database URLs, and autoscaling configuration. This makes deployments flexible across development, staging, and production environments. Subchart pattern for large platforms. In complex AI systems, multiple services work together. Instead of deploying them separately, an umbrella Helm chart manages all services using subcharts. For example, the main AI platform chart may include subcharts for orchestrator, specialist agents, inference server, and memory services. With this architecture, a single Helm upgrade command deploys the entire AI platform. Helm hooks for automation. Helm also supports hooks to automate tasks during deployments. Examples include pre-install hooks, run database migrations before pods start, post-upgrade hooks, run smoke tests after upgrades, pre-rollback hooks, capture system state before rolling back during failures. These hooks help maintain stability in production systems. Release management across environments. Helm makes it easy to manage multiple environments. For example, development deployment might run helm install AI platform /charts/namespace AI /f values.dev.yaml. Then configurations are gradually promoted from development to staging to production. Each environment simply uses different values files. Storing charts in OCI registries. Helm charts are stored as OCI artifacts in registries like AWS ECR. Example command, helm push AI agent chart 1.4.2.2.tgz OCI/register URL/helm charts. This ensures every deployment uses a version-pinned chart, improving reproducibility and reliability. Securing secrets with Helm secrets. Security is extremely important. Sensitive information, such as API keys, database passwords, and authentication tokens, are encrypted using SOPs and managed through the Helm Secrets plugin. Secrets are decrypted only during deployment, ensuring they are never stored in plain text in Git. Automated testing in CI/CD. To maintain quality, Helm charts go through automated testing. Common tools include Helm Lint, checks chart structure and best practices, Helm Unit Test, runs tests on rendered templates, KubeVal validates compatibility with Kubernetes APIs. These checks run in CI pipelines before code is merged. So, that's how modern AI platforms deploy complex systems using Helm charts, GitOps, and automated CI/CD pipelines. By combining Helm, ArgoCD, OCI registries, and secure secrets management, organizations can deploy scalable AI infrastructure reliably. If you want to learn more about AI engineering, DevOps, and modern cloud platforms, make sure to subscribe and follow for more deep technical explanations. Thanks for watching, and see you in the next video.